Hi mathematicians! We're going to learn how to make a model of a multiplication equation today. And the model that we're going to be using is called an equal groups model. Now models are really important in math. Even if you're a really advanced mathematician, using a model can really help you to very clearly explain and help someone else understand how you went through the steps of solving your problem. And in math, in real math, the steps and the strategies you used is much more important than what answer you got at the end. Because no matter what your answer is, if you can't prove it to someone else in steps that they can follow and agree with, you can't actually prove that your answer is right. So let's learn how we can communicate with other mathematicians to explain to them how we came to answers to our multiplication problems. And the first step is using a model. So we're going to start with a basic multiplication fact like this: 4 times 3. Now, this is mathematical notation. This is a sentence written in math symbols. This doesn't actually show us what's happening. It tells us in the same way that when we're reading a sentence made up of words and letters, tells us something. If we're reading something that's kind of complicated and the author is trying to explain something kind of tricky to us, they'll probably also add to their words and sentences a diagram or a model to show you what they're talking about. We're going to do the same thing as mathematicians. We're going to make a model to show what this math sentence is telling us. In this math sentence, I see 3 symbols. I see a 4, a times symbol, and a 3. And that tells me that I have 4 somethings. And in each of those somethings, I'm going to repeat 4 times 3. I have 2 ways I can show what's happening in a model. First, I'm going to draw the 4 things. Since this is a really simple model, I make it really simple. I just draw 4 nice circles. I want them to be a decent size also. You don't want to make your circles too tiny, or your math gets so crowded it's hard for you and anyone else you're trying to communicate with to understand what's happening in your model. So make sure you have a nice amount of space in each of your groups. So I now have this part of the math sentence, the math equation, shown in a math diagram or a model. Now I have to show this part. It says to repeat this number. I have to repeat the 3. I have a couple of ways that I could show this 3 repeating in each of these circles. One way I can do it is really to just draw 3 dots. If I choose to make dots, I want to make sure that my dots are really, really clear and they're right on top of each other in a nice line so I can really see them. And you can probably see why I want my circles to be a nice size now, because if these dots, if that's how I choose to make my model, are too crowded together and crunched, it's a lot harder to tell how many there are. So now let's look at what I've done. I've taken this math sentence, which was in symbols, 4 multiply 3, and I have shown it with a model that shows what's actually happening in this sentence. I'm taking 4 groups and I'm repeating the number 3, 1, 2, 3, or the quantity 3 in each one of the circles. Now I have another option. If I want to do it this way, I can use the same sentence, but I can make the model look like this. 4 equal circles with the number 3 in each one. And that's how I make a model to show you what's happening when I do 4 groups of each of these numbers, 3. Now sometimes I might have a larger number to represent, like 4 times 6. This is when being organized and neat is going to become super important. So again, if I want to use my dots strategy, I can, but there's a trick to make sure this stays neat. So let me show it to you. Again, when I look at these symbols, I know that this sentence is telling me that I have 4 somethings. In this case, my model is just going to be 4 circles. And it's like I'm going to repeat inside each circle 6 things. So here I'm going to make my circles again. I'm trying to make a nice size, even though I'm running out of space a little bit, because I never want to have my model be too tiny and crowded. Now I have to put in my 4 circles the 6. Oh man, that's going to be a lot more tricky than just doing 3. So this is my strategy always. When I'm putting a lot of dots or circles together, I want to start making them in groups of 5 to make a 10 frame. So I would start with 5 circles in a row, 1, 2, 3, 4, 5, and then I'd come up and add an extra one right next to it so I can see really clearly 5, 6. You might remember 10 frames from kindergarten and first grade, maybe even second grade. And they're just a really nice model to organize when you have a number of pieces like 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. That's another way to model it. You could, if you feel comfortable, just write the number 6 in each one, just like we did when it was 3. 6, 6, 6, 6, 4 times. Now here's one more strategy for people who are ready to move on from the dots, but putting together 4 6 is a little bit tricky. If that's something that you're kind of struggling with, here's one more way that you can make this a little bit simpler when you're making your model. Again, I'm going to make 4 circles. 1, 2, 3, 4. But this time I'm going to take that 6 and I'm actually going to break it apart into some numbers that are a little bit easier for me to work with. So a 6 is really the same as a 5 plus a 1. Is that right? If I have 5 plus 1, I have 6. And so I'm going to use that instead of 6. I'm going to say 5 plus 1 for each of my circles. Does each of my circles still represent 6? It does. Even though I put the ones on the outside, I can still tell that they're kind of in the same area of the circle. So I know that each circle is a 5 plus 1, a 5 plus 1, a 5 plus 1, and a 5 plus 1. And that's really the same as saying a 6, a 6, a 6, and a 6. But the reason I might like to break it up into a 5 and a 1 is because when I get into strategies, which we'll be using later, after we've set up a model, we use a strategy to solve the equation. Now I have a really easy skip counting number. I have 5, 5, 5, and 5. If you know how to skip count your 5s, you can solve the top half of your model. And then all you have to do is solve your 1s. And if you can count by 1s, you've solved the bottom half of your model and you can put them back together to get the answer. So if you're really struggling with this and these dots are not for you anymore, or not at all, you could try looking at your number, if it's a big number like a 6, and seeing if you can break it into an easier skip counting number. I always look for a 5. If I can't get a 5, I like to find a 2, something that's really easy for me to skip count. All right, mathematicians, that's how we do a basic equal groups model for multiplication.